Hi GD&T students. This is an example from Chapter 8. It covers Objectives 6, calculate the allowable bonus tolerance for a produced part on which a position tolerance is specified at MMC. And Objective number 7, use calculation techniques to verify whether produced hole locations meet specified drawing tolerance. This is a problem that was a lot like a problem on your Chapter 8 study guide, and I want to go over how to solve it. Okay, so first of all, we're given this drawing here with these 4 holes, and we have the 4 holes are located to datums A, B, and C by this feature control frame here. It has a MMC modifier in the positional tolerance, and it has a diametrical tolerance of 16 thousandths. And it also has a hole size here that gives us a maximum material condition of 0.282. Okay. Inspection data. This is the inspection data. Showing produced hole sizes and locations is also provided. The data has already been analyzed to determine delta X and delta Y variations. Calculate the diameter position variation for each of the 4 holes. Now, to do that, what we need to do is to calculate, well, in this case, your homework problem had you calculating these delta X's and delta Y's. And all we do is calculate this, we take the position, that's the actual location, minus the true position. Now, the true position of the holes is defined by these basic dimensions here. Okay, so x1, the actual position is 378 from the table. Our true position, which is where our tolerance is based upon, is 375, so that's this basic dimension right here. And if we subtract 375 from 378, we get 3 thousandths. And then we do the same for x2, x3, x4, and y1, y2, y3, and y4. Then the next step here is we need to calculate what the diameter position variation is. Now I want you to think about this as what is the diameter in which that hole falls. Okay, so this would be the outside diameter of the of where the actual hole falls. So if you take the true position point, which is defined by the basic dimensions right here, if you take that true position point and you calculate what your actual coordinate distance is from that. Okay, we do that by taking the square root of the sum of the squares for our x and y variations. Okay, and then we multiply that by 2. Okay, so that gives us 0.017 or 17 thousandths. Okay, so essentially what this 17 thousandths is, it defines the location, the actual location of your hole. Okay, and then we have to find the bonus tolerance. So our bonus tolerance would be the actual hole size minus the MMC hole size, and that gives us our bonus tolerance here. Okay, for example, hole 1 was machined to 284, and our MMC dimensions 282, so we get 2 thousandths bonus tolerance on that. Okay, and hole 2 we get 3 thousandths bonus tolerance because the hole is made at 285. And then hole 3 and hole 4 are very similar to hole 1 and hole 2. Okay, so now we go down to the last part of this problem, is we're going to use all of this data that we found up here, and we're going to determine whether or not the holes meet the true tolerance, the true position tolerance, the positional tolerance that's specified on our part. Okay, so 46 says, use the inspection data from problem 45 to answer this question. Determine the amount of bonus tolerance for each of the 4 holes in the produced part. Using the bonus tolerance for each hole, then use the data from your answer to complete the given table. And I've added some lines to this table to kind of make it mimic your homework problem from study guide. Okay, so what we have here is we put our bonus tolerance, which we calculated up here. We tabulated that here. And then now we have to find the allowable position tolerance, okay, which is essentially just our 16 thousandths true position. That's from our tolerance specification way up here at the top. That's 16 thousandths true position. Plus our bonus tolerance will give us our allowable position tolerance, okay. So we started with 16 thousandths MMC. And if we have 2 thousandths bonus tolerance, that gives us 18 thousandths. Okay. So now here comes how we check for whether or not the hole meets the positional tolerance. We take this diameter position variation. That's the one we calculated right up here. And essentially this is how far the center of your actual hole is from the true position defined by the basic dimensions. Okay, and now we compare these two dimensions, and as long as this diameter position variation is less than your allowable position tolerance, then the hole location is acceptable. Okay, so in this case we calculated a diametrical position tolerance variation of 17 thousandths. Our allowable position tolerance is 18 thousandths, so therefore it's good. Now the other holes seem to do a little bit better. This one was only off by about 9 thousandths, and hole number 3 was only off about 9 thousandths, and then hole number 4 was only off about 12 thousandths. Okay, so this is an example of how to do the study guide problem in your homework. Thank you.